My name is Carryl Baldwin. I'm an associate professor here at George Mason University in the Arch Lab. And my primary research interests are applied auditory cognition, and specifically usually in transportation environments. So driving and flying kind of our two main areas. We do a lot of work currently on designing auditory displays, warnings, alerts, signals for transportation driving settings. So the National Highway Traffic Safety Administration has had us looking at issues of alarm reliability, negative transfer. What happens if you get used to one particular alarm and then you drive and you're used to having a suite of sounds that alert you to different things, and then you drive a vehicle that you've never encountered before and it doesn't have those alarms, or it has different ones. What happens? Could it maybe cause more harm than good, kind of a thing? So in that research, we use a variety of things. We use a motion-based driving simulator. It's actually one of the few in the country that's actually a motion-based, so it not just goes up and down and forwards and backwards, but will rotate as you turn left or right or whatever. It spins around. And we have a full range of auditory equipment that you might not think of as being, so obviously things like microphones and recording devices, but also professional grade sound level meters and things like that for checking, the auditory quality and analyzing frequency of different sounds and things, so we can identify a sound anywhere, like record it and then bring it back and figure out what components make up that sound, kind of a thing. We also use a lot of neurophysiological measures in our research at different times. So EEG, electroencephalographic recording devices, and the subcomponents of that, ERPs. We also use heart rate, like monitors and things like that, and so ECG we call that, and kind of alphabet soup, EMG, so looking at muscle tension and things like that, with the idea of, like, as you're driving a car or performing some other kind of a task, you're going to tend to be more tense. As the work gets harder, or in fatigue applications, because we do some driving and fatigue research, if you're falling asleep, probably you'll let loose of the steering wheel and things like that. So we can use both EEG and EMG and ECG to monitor driver state and operator state in general, I guess.